This video is a part of the A to Z series of Python language where I go through all the built-in functions of Python starting with letter I, with the description of how to use them. The imported library functions and classes are written using these built-in functions only. So you can consider this as a foundation of the entire Python language. If you have landed directly on this video, you can check out the entire playlist in the iCard above or through the link in the description. Otherwise, watch this video till the end as I will also give real project examples where these functions might be useful wherever I can. My name is Aditya Shenoy from Brainy where I make programming simple and fun. YouTube statistics show that a small percentage of you who watch my videos are actually subscribed to this channel, so if you end up liking this video, please consider subscribing. It's free and you can always change your mind in future. The first function is the id function. It takes one parameter which can be an object of any type. It returns an integer identifier of that object. The C Python implementation states that this number returned is the address of the object in memory. Suppose we have two variables A and B and we initialize two string literals to these variables, and now if I try to print the id of A variable, B variable, we see that these numbers are different. We can check for their equality as well, id of A equal id of B, and this will lead to a false because it is natural. They are different variables holding different values. But if we have two variables having the same values like this, A equal to A and B equal to A, and if I copy this line and run this, you will get same id values for both variables and it true for their equality. But I just said that the id returned is the address of the object in memory. So if these two are different variables, how come the IDs or their addresses are the same? This is because memory is allocated to the values instead of variables. In this case, a string literal of A is initialized in memory, and when we assign it to a variable, a pointer of this address of string is stored in the variables. So even though the variables are different, they are pointing to the same object address. But if we assign a different value to any one variable, like in the first case, that variable will point to a different address, and thus the IDs returned in the first case came out to be different. If you create a variable and then delete it, then the memory allocated of that variable is marked as free. A equal to A, id A is id of A, and then I will delete the A variable. After this, I will create another variable B, id B equal to id of B, and then I will check for the IDs of id A, id B and their equalities. So after deleting the variable, if we create another variable, then it is completely possible that Python will use that free memory space to allocate the new variable. Two objects with non-overlapping lifetimes may have the same ID value. In this case, they came out to be different, but they can come out to be same in some cases. IDs can be used to test equality of values, although you will use double equal to sign or is operator, but there might be some applications where you want to assign a unique number value to each object in your code, just like the social security number or Aadhaar number. These numbers don't say anything special but apart from their uniqueness. The next function is the input function. As the name suggests, it takes string inputs from the users. This input is taken from the standard input, which in most cases will be the command prompt. If I make a variable name and assign the input's return value to the name variable and then print the value assigned to the name variable in the second line, and if I run this, as you can see that the program has stopped at this first line and it is asking for me to enter an input. So in this case, I will enter my name and press enter, and as you can see, this was my input and I have printed my name. The type returned from this function is of the string type, so make sure you convert it to numeric form if your program takes numeric inputs. This function takes an optional parameter, which is a prompt which is displayed to the user while taking the input. So I can enter a string, enter your name, and if I run this cell, as you can see, the prompt that we asked Python to display along with the input text box is correctly being displayed, and then we can enter our input as normal and it will print the same output as before. You should definitely use these prompts so that users can understand what input they are expected to enter, what are the options like male or female, or format like date format of the input. Such information can be displayed to the user using this prompt. But don't use prompts when the code is tested automatically as in the competitive programming, because the prompt is printed in the output region and that will make your output wrong. Input function is a very common function in competitive programming. It is also used if you are making a console application where users enter input on the command prompt itself. The next function is the int function. If called without any parameter, like this, it returns a default value of 0. If you pass any object to this function and that function has the double underscore int double underscore method implemented, which converts objects to integer, then this function calls this double underscore int double underscore function and returns an integer object. So if I pass a string object inside this and pass some numbers in string format, it will convert that string to integer object like this. Passing a float value will return only the number preceding the decimal point, truncating the digits after the decimal point. As in this case, 0.5 has been truncated and only 2 is returned. If the string object passed inside the int function cannot be converted to an integer, like 123a cannot be converted to an integer because a is not a valid number, it will raise a value error like this. This function takes a second parameter too. If the first parameter is of string, bytes or byte array type, then the second parameter can specify the base of the string from which we have to convert the number to decimal number. So if we pass a binary string like this, int a string of 101, and we pass the second parameter as 2, we are telling Python that the string passed in the first parameter is in base 2. Then it will convert the number to a decimal number. Like in this case, it has converted it to 5. The second parameter can take any non-zero positive base, out of which common bases are 2, 8, 10 and 16 for binary, octal, decimal and hexadecimal respectively. This function is very useful to convert data types from different objects like string or float to integer. With the second parameter, numbers from different bases can be easily converted to the decimal base, which is very handy when you are given a bit level algorithm to solve. The next function is the isinstance function. This function returns a boolean whether the given object is an instance of a particular class or not. This function takes two parameters. First parameter is the instance or an object of a certain class. So I will pass false, which is an instance of a boolean class, that is bool class. And the second parameter is the class info, which can be the class name. So I will pass bool, and if I run this, it returns me true because false is an instance of bool class. We can also test for other classes as well, false and int. It will still return me true because false is also a numeric type and false can be interpreted as a zero value, which is technically an integer value too. So false is an instance of integer class as well. But if we pass is instance false string, then it will return false. Suppose we want to check if an object is an instance of one of the given classes. So what you can do is instance false bool, or I will just copy this, or string, and this will be int. And if I run this cell, I will get a true value because the object false is an instance of boolean as well as integer class. And the OR operator returns true if any of these values return true. But this is a very big code. So instead of writing this much code, there is an option to pass a tuple of values, tuple of class infos as the second parameter of isInstance function. So isInstance, the object that we need to check is again false, and we will pass a tuple of values. In this case, it will be bool, int, and string, and that will return the same output as before, that is true. This function might not seem useful as Python is not a type-strict language, but for production level codes, it is a good practice that each function first checks whether the parameter passed is an instance of correct class, that is, it is of a correct data type. Validating the types of parameter or the user input first will prevent a lot of unwanted errors in the future. So keep this function in mind to write a good code. The next function is the issubclass. This function returns a boolean whether a class is a subclass of another class or not. Let's create three classes. The first class will be grandparent. I will keep these classes empty by passing the pass keyword. The second class will be parent class, which will extend the grandparent. In Python, you extend classes by passing the parent class name inside a parenthesis like this. I will again pass the pass keyword, and the third class will be child class, which will extend from the parent class and again a pass keyword. Now if I test is subclass child, this function takes two parameters which should be class names like this, and if I pass two same class names, it will return true because every class is a subclass of itself. Now I will copy this and I will change this to parent. So child is a direct subclass of parent, so this will return true. But what will happen if I pass an indirect extension classes like child and grandparent? It will still return true because child is indirectly a subclass of grandparent as well. But if I pass parent, parent and child, it will give me false because parent is not a subclass of child, it is a superclass of child. Just like the isInstance function, the second parameter can be a tuple of class infos. Is subclass child, and I will pass a tuple of child, parent and grandparent like this, and it will return true if this class is a subclass of any one of these class infos passed in the tuple. This function can be used with the isInstance function to validate the data types of the user inputs or function parameters. There are some object-oriented applications where the function parameters can be any valid subclass of a particular class. So you might want to use this function to validate parameters in this case. The next function is the iter function. It returns an iterator object constructed from the object passed to the function. If we pass only one parameter to this function, then the object needs to define a function of either _iter or the _get_item. So in this case, I will define the getItem function. Class even iterator, I will create a custom class and define the _get_item and pass the self keyword. Apart from the self parameter, it should take one more integer parameter which will be the index of the iterator. And based on this index, I need to return the element that is expected on this index in this given iterator. So as this is an even iterator, I will just return x into 2. So I can use for loop now for I in iter, and I will pass even iterator like this, an object of even iterator class, and I will print I just like this. And if I run this, I need to interrupt my kernel because this will run infinitely. It will print even numbers infinitely, and I had to stop this program because otherwise it will have crashed my system. In this case, Python does not know when to stop. So you can put an if condition inside the for loop if you want. So I will put if I equal say 16, I want to break. And if I run this, it will just loop until 16 is reached, and 16 is not printed because the loop breaks before printing 16 value, and it prints bounded iterator. You can use this get item function when you don't know the bounds of the iterator and when the elements of the iterator have a fixed relationship with the indices, like in this case. The second option is to define the double underscore iter function. In this case, the object returned by this function should be an iterator object. So I will create another custom class, in this case odd iterator, and I will define double underscore iter function. I will also need to define the constructor, in this case init self, and I will pass the bound of the iterator, that is the maximum value of this iterator, inside the constructor itself, self.max equal to max. And inside the iterator function, that is double underscore iter function, I will return a range object 1 to self dot max comma 2, and this iterator function should return an iterator object and not a range object, so I need to convert this to an iterator object. And now I can use for I in iter or iterator, and this time we need to pass the bounds inside the constructor, so I will pass 15 in this case, and I will print I. This time we don't need to add this if condition because we already know the bounds of the iterator, and in this case it will print 1 to 13, not included the 15. Also, you don't need to pass the iter function like this if you are using it in a for loop. So if I skip this iter function and run this, because Python knows that if you are using this object inside a for loop, then this function, this object should be an iterator object, and it automatically calls the double underscore iter function or the normal iter function and pass this object inside the iter function. So you can use this code and the output will remain same. There is one more way we can create iterators. If we pass two parameters to the iter function, then the scenario changes. The second parameter is the sentinel value, that is the value on which the iteration should stop. So to demonstrate this, I will create one more custom iterator, multiple iterator, which is an iterator to generate multiples of a number. So I will write the constructor self num. This num parameter inside this constructor is the number of which we are generating the multiples, self.num equal to num, and self.current equal to num. This current value will be returned as the elements of the iterator, and this num value is just for initialization and incrementing purposes. Now if I call for I in iter multiple iterator, I will pass 3 to this constructor as I want to generate multiples of 3. And if I pass the second parameter, that is the sentinel value, as 33, this is the value that we are telling Python to stop this for loop at. When we pass the second parameter, the first parameter object should be callable with no parameters and should return the next value of the iterator. I have created a detailed video on the call function which you can check in the iCard above. So I will define the double underscore call double underscore function. I will pass just the self keyword because this should not have any other parameters in it, and I will increment self.current by self.num, and I will return self.current minus self.num. We can either store the old value of self.current in another variable and then increment and then return the old value, but we can write the same logic in this way as well. Now, when this returned value becomes equal to the sentinel value, stop iteration is raised, which causes the for loop to stop. So inside the for loop, I will just print the I value, and as you can see, all the multiples of 3 is printed properly. In this variant, the custom class does not have any idea of the bounds of the iterator that the caller is expecting. It is the responsibility of the caller function to specify the bounds of the iterator. Also, the element of the iterator need not be dependent on its index in the iterator because we are not associating any element to its index. Iterator functions are very useful when you want to say generate a custom dataset generator which generates images from your file system. It can also be used to generate specific numbers like Fibonacci numbers generator or any other iterator that you want. There might be some applications where you might want to define your own custom iterator classes by using one of the three variants that we discussed in this video. So these were all the built-in functions that start with letter I. If you ended up liking this video, please press that like button, comment any feedback that you have for this video or this channel, share this video with your friends. The code that I write in all my videos of this channel is available in my GitHub profile, whose link is in the description. You can connect to me via LinkedIn, whose link is again in the description, and I will see you in the next video.